A good project can lose value if it isn't communicated properly. Today, I'll be walking you through the process of making creative visuals to present your research. Let's start off by talking about posters. Unlike papers, these are visual ways to communicate your work. They are often displayed at conferences along a wall or corridor, so people who walk by can see them. Generally, including a title and making it look nice is enough to do so. Add colors to your posters, and if you are making a trifold by hand, make sure any cut lines are straight and that everything is glued down properly. Though you will likely be presenting your poster, many events also include poster reading sessions at which you might not be present. To ensure people don't get confused when you're not around, allow your poster to communicate for itself. By this, I mean that it should tell the story of your project by providing all the relevant information. What background information do people need to understand your project? What steps did you take to test your hypothesis? Ensure that you don't have any undefined scientific jargon or symbols that you would need to be present to explain. Your poster should also appeal to your target audience. If you know a competition's judges are experts in their field, make sure that you make a point of providing detailed scientific context, analysis, and descriptions. However, if your poster session is open to the general public, break any complicated information down into terms most people can understand without having expert knowledge of your topic. There are also different formats for a poster. These include virtual posters, which are displayed on screens, hanging posters pinned up on walls, and trifold posters on tables. The different poster types are varying dimensions and formats, so you want to make sure your design is readable in all formats. For example, ensure your figures don't lose resolution once printed out. Next, we're going to go over a basic poster layout. This is the trifold layout that I was taught in school. You start off with a large title. This is part of an attention-grabbing aspect of a poster. In this format, you tell your story from left to right. Start with a scientific background people need to understand your topic. Keep this relatively brief though, and don't use a giant wall of text. We'll talk about this more later. Next, describe your methods. If this poster is going to be used at a science fair associated with the Society for Science in the Public, for example, leave space for your abstract in the lower left corner of your poster to qualify for the competition. In the middle, we're going to talk all about what you actually did in your project. Start off by adding your purpose and hypothesis at the top. This placement is also good because people's eyes typically start in the middle, so they can understand the general gist of your project just by reading these two elements. Below that, add your results and pictures. Make them relatively large so you can point at them as you describe your poster. Again, placing these visuals in the middle helps them catch people's attention. When you add your results though, don't include any raw data. Make sure everything there has been analyzed and polished. At the very bottom of the section, add a brief written analysis. This will help people understand your poster when you aren't around to describe it. The left side of the poster is dedicated to the implications of your work. What did you get out of it, and what can other people get out of it? Start off by discussing the conclusions you got out of your data. Was your data statistically significant? Was your alternate hypothesis ultimately supported or rejected? Below that, talk about the applications of your work. What broader implications will it have for science? Next, discuss the limitations of your experiment. What changes could improve your data? Maybe you could have included more experimental trials, or maybe your mathematical model had some shortcomings. The next section is similar to limitations, but it focuses solely on the errors of your experiments. These may be things like human error if you had to manually stop a timer during your experiment, or the error included in the measuring devices you used. Close your poster out by discussing future research. If you were to continue the study, what would your next experiment look at? I really like this format because it covers all of the bases of a project, enabling readers to gain a thorough understanding of what you did. However, one of my college professors showed me a Reimagined poster layout that I found quite interesting. This layout is centered around the fact that people are going to be walking past your poster. It emphasizes high readability. The Reimagined layout includes a one-sentence conclusion at the front and center of your poster. Readers can understand your project without even having to stop and examine the poster. On the left, it has the project's title, a brief background section, methods, results, and a discussion, as described on the other poster layout. The right side of this poster focuses on the data collection. It includes data and methods. Finally, it has a QR code in the middle that links to a paper. The logic here is that if people are really interested in learning more about your project, they can scan the code to get a more thorough description. You can also add QR codes that link to data collection videos. I like that this poster is more interactive than the other layout, and it functions well for fast-paced environments. However, I would not recommend it for a science competition or pair because it is not as thorough as the other option. Next, let's discuss poster design. Color is important to a poster because it helps with the general mood of your project and makes it more attention-catching. Some color schemes can be based on your school colors, the colors that you use in your experiment so your borders match your images, or the colors that you like. As long as the color isn't too bright or distracting, choose whatever color you like. Incorporate it into your poster by using it as a backing behind larger chunks of text, and maybe even make it your font color if it's legible. Speaking of fonts, you want to make sure that everything is big enough to read. Your title should be large enough to read from afar, and the author names should also be quite big. From there, your headings can be a little smaller, and your text can be small enough to fit everything in. This image suggests 24 point be your smallest size. When you make your poster, also consider accessibility. Italics can be hard to read sometimes, so if you want to emphasize a point, consider bolding and/or underlining it instead. Some fonts are easier to read than others. Avoid anything too frilly, including cursive, or small, like handwriting-inspired fonts. Calibri, Arial, and New York Times are great options for poster fonts. When you make your poster, also avoid giant blocks of text. These are harder to read and can even come across as disorienting or intimidating to readers. If you need to convey something text-heavy, like background information, break it into bullet points instead. Alternatively, you can use pictures to talk through elements like methods. Show what you did instead of telling it outright. Again, font size and legibility play huge roles here. People don't want to have to work to read something, especially when the content itself is so information-heavy already. Especially when you're presenting your work, cut down on this intimidation by explaining your text out loud. So let's walk through just how to show instead of telling. When you present data, never use raw data. Always beautify it into charts and graphs. A chart looks like an Excel spreadsheet. These are good ways to give your readers an idea of what your collected data look like. However, a graph is an even better way to show the trends of your experiment. Different data sets are presented best in different types of graphs, so it's important that you choose the right one for your data. Bar graphs are great ways to show quantities. Dot graphs are awesome for trends over time, and pie graphs are great for proportions. When selecting the type of graph to use, try different options and go with the one that you think is most readable for your data. When choosing which photos to use, emphasize the storytelling of your poster. I sometimes include pictures of the materials I'm using, especially if they involve custom-created setups or designs. If your results are visual, like heat maps or bacteria growth, include pictures of any interesting results. You want your photos to really paint a picture of what your experiment looked like, so readers can imagine themselves in your experimental setting. However, also consider when to use images instead of text. Some events have specific rules around the pictures you can include, and some sections are better presented as text. For example, diagrams can be beneficial for your background information section, but it's also important to include text explicitly telling readers the information and definitions they need to understand. We've been talking about all these images and graphs and designs, but how would we actually go about making them? Fortunately for us, there are a ton of digital resources around poster design. Canva is a great option for overall design. It also includes a few templates, as shown on the left of this picture, that you can base your poster up on. Google Slides and PowerPoint are great for slideshows, but did you know that you can also use them to make posters? As seen in this picture, you can use the Shape tool to create backdrops for your text and organize your poster. Really a great option if you're already familiar with the software, as it enables quick and effective poster design. If you're focusing on data analysis, Google Sheets and Excel are great options for number crunching and graph making. There are tons of mathematical formulae built into the software, so you don't need to do as many calculations by hand. Their graphing programs are also awesome. They allow you to customize nearly every element of your graph, from error bars to the color of your data points. Many students haven't heard of BioRender, but it's one of my favorite programs. This one is incredible for making figures for your graph. They have a database of free basic images you can use to provide more detail around your methods or background. BioRender's website also shows that you can make posters and even graphs using the software. It really is an all-purpose program. To close out, I wanted to throw in some extra tidbits I learned the hard way from making posters. Especially for hanging posters, start thinking about assembly and printing ahead of time. Printing can get expensive, especially with short notice, so here are some options for doing so. Find a print store near you ahead of time. Often stores like FedEx are great for this. They often have different options, and here are some benefits of each. Textile printing is great because it's durable, but it can also be hard to hang without stretching or deforming the fabric. Gloss looks professional, but it can be hard to read in certain lighting because of glares, and also ends up being quite expensive. Matte printing is my favorite. It's generally legible and not too expensive. Thin paper is also a great option if you're operating on a tight budget, but be careful not to tear the paper during transport. Now that you've printed out your poster, you want to transport it without breaking anything. Many stores sell cardboard tubes or fancier poster carriers so you don't deform your work. Alternatively, you can roll your posters up and tie them with a rubber band. If you made a trifold, you can put it in trash bags to prevent scuffing during travel. Whenever I travel with a trifold, I also like to bring a glue stick with me in case anything peels off during the commute. Finally, let's talk about extra presentation materials. Science fairs may require you to add a stamped abstract to your poster, so allow the space and time to include that. If you have tangibles for your experiment, like mock-ups of your experiment or other visual tools, you can also bring those separately and use them to talk through your work. That covers everything for Module 3B. Happy poster making!